Teacher, what slide is this?
This is slide number 45, I believe.
Okay.
45, yes. Did you not find this? All right, let's
No,
continue.
I'm searching for that.
Do you have a question?
No, 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 no.
All right, cool. All right, so this is absolutely easy, right? This is one of the easiest equations we can solve that are quadratic. These are quadratic because they have the 2 as an exponent, right? These are quadratic equations. But what happens if we are talking about negative numbers? What would be the square root of -9? Because that is how you solve this, right? I have x squared equals -9. If we do the same process, if we do the exact same process, we would have that to take out the exponent, we make it into a root on the other side of the equation. And that root can be both positive and negative, just like we did in our example. But now the question is, what is the square root of -9? Please don't say -3. No, no, no. That doesn't work. In the past, we have learned that negative numbers don't have a root. Negative numbers don't have a root. So how can we solve this equation? Pretty simple. We remember that the root of a negative number is also the root of the number with an I. This is the square root of -1 times 9. And the square root of -1 is the letter I, our imaginary unit. So by doing this change, we took out the negative inside of the root. And now we can solve this thing. Because now we know the square root of 9. This is 3. Positive and -3. So this one, x squared equals -9, has the solutions.
Teacher, the I goes inside the root.
No, absolutely not. Look, the root
Okay.
gets right on the edge of 9, right on the edge of 9 here. If it was inside, then the root, the line of the root, look, it'll have to continue all the way over here. Okay? Just like this one. Look, this root is a little bit longer because it has to contain everything. This one is not. It's just gonna finish here because it's just containing the 9. All right, so this equation has 2 solutions. One
Thank you,
is
teacher.
positive 3i, and the other one is negative 3i. 2 solutions. So now we know, guys. Now we know every equation that has a square, right? A square exponent, an exponent of 2, can have solutions. Maybe there are real solutions like these, and the regular numbers that we all know. But maybe they are not real numbers. Maybe they are complex numbers with the I. All right. Let's try to solve this equation then. Solve the equation x squared minus 4x plus 8 equals 0 in the complex number system. We're going to solve this equation. And if we remember our algebra, we know that this is a quadratic equation, right? Ax squared minus bx plus c. This is a quadratic equation. So we solve it with the quadratic formula. Do you guys remember this? This is the quadratic formula. If you go into your notebook and you look for it, you're going to find it. I'm sure you're going to find it. We use this quadratic formula to solve some quadratic equations in the past, right? Let's see if anybody remembers. How did you call the thing inside of the root? This thing has a name. This is called the what? In the chat, please. Beautiful, Tefa. The discriminant. You are correct. This is called the discriminant. So we use this in the past a lot, right? We use this in the past a lot. All right, don't worry if you don't remember. You just have to change the values of A, B, and C for the values of the coefficients here. This is how you do it. Here you know that the coefficients are A, B, and C, and the values are 1, -4, and 8. How do we know that? All right. A is the coefficient of the x squared. So here, right here, the number that multiplies the x squared, this little number. Since there is nothing, that means that coefficient is a 1. Same with b. B is the coefficient of the x, so the number that goes with x, the number that multiplies x. Numbers are also with signs, so b is not 4, it's negative 4. There we go, negative 4. And then the c is the number at the end, the constant value. This one is positive 8, so c equals positive 8. There we go. We have our values. All we have to do is replace them in the formula. Look at that. Negative 4. Look, it's negative b. So negative 4, right? Double negative. Plus or minus, because we have our plus or minus here. Plus or minus means we are going to have two solutions, one positive and another one negative. So we are going to have two solutions. From here, we have the square root of b squared. We know that b is negative 4, so negative 4 squared is 16. Minus 4 times a times c. AC. 1, 8. A, C. Look at that. All we have to do was replace. Down in the denominator, we have 2 times a, so 2 times 1. If we put this inside a calculator or just do the mathematics, we are going to have that this positive, negative, and negative means positive, right? So we have positive 4 plus or minus negative 16. This is 16 minus 32, right? 4 times 1 times 8, this is 32. So 16 minus 32, that would be negative 16. So now we have a problem. Now we have a negative number inside a root. But we learned in the past that we can take out that negative with the help of our imaginary unit. If we do that, we know that the square root of negative 16 will be 4i. This is the square root of negative 16, 4i. And we know that root can be positive and negative. So we have our positive and negative. From here, simplify this with the denominator, right? 4 divided by 2 is 2. 4 divided by 2 is 2 as well. What we did was sort of splitting, sort of separating the two, just like we did in the past in divisions. Remember in division where we had to separate the fraction, the denominator, sorry. The denominator goes with one number and also with the other one. Right? If we do that, then we can cancel these. So these will be our solutions. Now, since this is a quadratic equation, that means this has two solutions. One is with the negative sign. Look, 2 minus 2i, 2 minus 2i. And the other solution is with the positive sign, 2 plus 2i, 1 and the other one. There we go. Now, there is something really interesting about these two numbers. This is a number, right? This is a complex number, right? Look at that. Real and imaginary, right? This is a complex number. And this is also a complex number, sorry. Real and imaginary, right? Let's see who gets it in the chat. Please tell me, what do you guys think is the relation between these two numbers? Look at them. Look at the numbers and tell me, what do you guys feel like is the relation? Let's see if any of you remembers. In the chat, please. Okay, seems like nobody got it this time. All right. This relation is called the conjugate. We know about the conjugate of a complex number. We know that. 2 minus 2i, right? And 2 plus 2i. These two are the conjugates, right? This is the conjugate of this, and this is the conjugate of this. Because we have the real part the same and the imaginary with the different sign. So these are conjugates. And that will happen every single time. Every single time this will happen. The solution of quadratic equations that are complex numbers are going to be the conjugate of each other. And that is beautiful. That is one of those coincidences in mathematics that is just beautiful. All right, let's continue. We have some exercises here. We're not gonna do this today. We're gonna do this later. All right. We're gonna do this later. We are gonna do them today, but not right now. We're gonna do them later. And now we have a new topic for today, polar coordinates. Now, don't get scared. Please don't get scared about this name, right? Don't get scared about this. This is absolutely easy. So easy that we're going to begin with something new called the radians. Guys, if you like to take notes, go ahead and take notes about these radians. What are radians? All right, radians is a new word, something new we haven't learned we haven't seen in the past. So we're not gonna learn that today. Radians are a different unit for angles. In the past, we measure angles with degrees, right? The little ball right in the corner of a number, those are degrees. So we can say alpha equals 45, and then 45 degrees because of the little ball, right? We know that. But now we can use a different unit. We can use radians. Radians is another unit, right? Just like centimeters is a unit and meters is another unit. Just like liters is a unit and deciliters is another unit. These are different units for the same thing. And since there are units, there are formulas to convert from radians to degrees or from degrees to radians. These are gonna be the two formulas. If you guys like formulas, go ahead and take a picture of this right now. Take a picture or write them down. How do you use this formula? Simple. Let's say you have a number in radians. This is the unit for radians, rad. This is the unit, rad. So let's say you have a number in radians and you want to change it into degrees. You are going to use the first formula, the first one. Because in radians, here, instead of the word rad, you are going to write the number that you are given, the number in radians. Multiply by 180 divided by pi. Just put that inside a calculator. And then you are going to have the number in degrees. Huh? But let's say maybe I give you 45 degrees. Maybe I give you 45 degrees, 30 degrees, 108, whatever amount of degrees. So, and I ask you to change it to radians. We are going to use the second formula over here. The second formula is the one we are going to use, right? Instead of the word degrees, you put inside the number that I'm giving you in degrees. Put this inside a calculator, and there you go. You have radians. That's simple. Now, all of this is easier to learn with an example. So here is the example. Let's try to convert some degrees to radians. I am giving you the numbers in degrees. Now, how do you know these numbers are in degrees? Because look at that. They have the little ball in the corner. This is the unit for degrees. This is the unit for degrees. All right, this right here is the unit for degrees. So we know these are in degrees because of the unit. We can see the unit, right? We can see the unit. How do we change it to radians? All right, we are gonna have to use a formula. The formula we are going to use is this one over here. Since I am giving you the number in degrees, you are gonna have to use this formula over here. Simply put the number instead of degrees, put it in a calculator, and you got it. So for this exercise, guys, what I need you to do is right away, right as fast as you can, go ahead and grab your calculator, because this one, we are going to do it with calculator. This exercise, we are going to do it with calculator, right? So by the time of 5, I am going to continue with this, hoping that you all got your calculator. 1, 2, 3, 4, and 5. Beautiful. So let's continue. Changing 60 degrees into radians is as simple as this. Put 60 instead of the word degrees, right? The formula says degrees times pi over 100. So that is what I have here. 60, which is the degrees, times pi over 100. The word radians, this is just the unit, right? The unit at the end. We just took the 60 and multiplied so that we get radians. If we put this inside a calculator, let's see Who gets the answer? Now, this is the simplified version. You can leave it like this, or you can put it in a calculator. So how much is this in a calculator? Let's see who gets it in. Let's see who gets it first. That's what I wanted to say. All right. Nata Obando, Majo Roa, Tefa Cabrera, and Daniela Ruiz. Let's see if you get it right. Okay, beautiful. One of you decided to round it. Two of you, sorry, decided to round it. So congratulations to Majo Roa and Tefa Cabrera. Nata and Dani, remember to round, guys. The next number was a 7, so this one becomes a 5. Beautiful, 1.047 radians. Remember, the unit of radians is the word rad. So I can just, instead of writing radians, I could have just wrote rad. And it will be okay, right? Beautiful. So if I do it with 150, all I have to do is, instead of degrees, write the 150 right there. Put it inside a calculator, simplify if I can. And then the solution will be, let's see who gets it first. We have Majo Roa, Dani Ruiz, and Valerie Nicole. Let's see who get it correctly this time. It is round to 2.618 radians. So congratulations to Valerie and Dani and Majo and Tefa. Man, all of you got it correctly this time. Beautiful ladies, beautiful. Beautiful ladies. All right, couple of important things to realize here. Number one, notice that sometimes I use the equal sign, look, the equal sign, and sometimes I am using another sign. This is the sign for rounding, for estimating, for saying a number is around something. This is an approximation. This is not the exact solution. 1.047 is not the exact solution. 2.618 is not the exact solution. This is a solution I would accept in a quiz, but this is not the exact solution. If an example, an exercise, or maybe a question in a quiz ask us to find the precise, the exact solution, then these are going to be it. The simplified versions of the formula. How did you simplify? You guys know that 60 divided by 180, this can be simplified, right? You divide by 10, then you have 6 over 18. And then you divide by 6, so you have 1 over 3. Then you go 1, nothing. Did you see it? Nothing. 1 over 3. It is as simple as simplify. This is the simplified version. And this is what you guys write if I ask you for an exact answer. If I don't ask you, or maybe the book doesn't ask you, or maybe Alex doesn't ask you for a precise answer, then this is a good answer as well. All right, let's continue. Let's go for C and see who gets it first. Now, for this one, for the C, since you see here a negative 45, a negative number, then you are probably going to expect a negative radian. Look, negative 45, just put it in the calculator, right? You simplify it if you want to. And then the solution, let's see who gets it first. Negative 0.785. Congratulations to Tefa Cabrera, Daniel Osorio, and Majo Altamar. Beautiful guys. You guys got it correctly. It is as simple as that. Just put the number instead of the word degrees and inside a calculator. And there you go. Just like that. Now, in order for you to don't have mistakes, to don't have issues, don't write 3.15 for the pi. No. Your calculator has the letter pi on it. Your calculator has it. You just have to look for it. Now, if you don't know where it is, let me open mine and I'll give you a quick instruction about where it is. My pi is, look, if you go to the arrows that let you move, right? Right under those arrows, you're gonna find the key clear, right? And right under that, you're going to find like a little B, but upside down, right? On top of that bottom, on top of that one, you are going to find the little p, the little pi, sorry, as blue. You guys got it? Meaning all you have to do is do second and then the key. And there you go. That's the pi. All right. 90 degrees. Let's see who gets it first. 90 degrees is going to be 90 times pi over 180. We can simplify this. This is pi over 2. And pi over 2 is exactly 1.571 radians, which means, congratulations, all of you. Congratulations to Tefa Cabrera, Cata Castro, Nata Quintero, Valerie Nicole, Daniel Felipe Osorio, and Majo Roa. Man, you guys got it perfectly. Beautiful. Now, the next one, 107 degrees into radians. There are some cases where we cannot simplify. This is the simplified version. This is the simplified version. We cannot simplify these numbers any further. So all we can do is write the solution as approximate as we can. Let's see who gets it first in the chat. Whoosh. 1.868 radians. Congratulations to Tefa Cabrera, Majo Roa, Cata Castro, Mariana, Mari Sainz, Dani Osorio, Nata Quintero, wow, and Majo Altamar. All of you guys, man, all of you, beautiful guys, beautiful. More and more guys are getting the hang of this. Beautiful. Now, let me ask you something, guys. In the chat, I want the 24 people who are connected right in the chat. Is this easy or is this hard? Right now, please. All right, we are getting some answers now. All right, beautiful. I have 9 answers so far. And all of you are saying easy, 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 easy. Beautiful. All right. I feel the same as you guys. I feel like this is absolutely easy. Now, I said at the beginning, you can change from degrees to radians. So let's change back now from radians to degrees. And that is exactly what we're going to do next. From radians to degrees. Here is the number in radians. There it is, the number in radians. Now, since it is in radians, then we have to use this formula over here. This is going to be the formula. Instead of the word rat, just write the number. Pi over 6 or 3 pi over 2, whatever the number is. If we put this in a calculator and we then press the enter button, we are going to have the answer. So let's see who gets the first one first. Pi over 6 is the number in radians multiplied by 180 over pi. 180 over pi. But this is beautiful. Look, in this case, the pi and the pi gets canceled. So we have 180 over 6. This is 30. 30. And don't forget about the units. We put the little circle on top of it because these are the units. 30 degrees. Now, look at this. I am not rounding the number. This is the equal sign because this, in this case, this operation gave me a precise number. How beautiful is that? Sometimes that happens. Congratulations to Majo Altamar, Valerie Castro, Nata Quintero, Tefa Cabrera, Santi Camacho, and Dani Ruiz. Let's go for the second one. 3 pi over 2. We put this inside the calculator. 3 pi over 2 times 100 over pi. Cancel the pi and then do the algebra. We have 270. And 4 people got it before me. Beautiful. Majo Roa, Nata Quintero, Dani Ruiz, and Tefa Cabrera. I am going to do this a little bit faster. Let's see who gets the C1. We have a negative number, meaning we are expecting a negative degrees. Simply whack it inside of a calculator. We have negative 3 pi over 4 times 180 over pi. Cancel the pi's, do the multiplications, the divisions, and we have negative 135. Ooh, beautiful, guys. Cata Castro, Dani Ruiz, Majo Roa, Valerie Castro, Mari Sainz, Nata Quintero, and Tefa Cabrera. Beautiful, guys. Beautiful, guys. Beautiful. Next one, 7 pi over 3. Inside the calculator, multiply 420. Congratulations to Nata Obando, Dani Ruiz, Majo Roa, Tefa Cabrera, and Cata Castro. And before I continue with the next one, look, are you guys familiarized with the 420 meme? 420? Yes or no? 420? All right, if you are, if you know the meme about this number, then you can take it a step further. Instead of writing 420, you can write 7 pi over 3. And now you are making a meme out of 420. All right, for 3 radians, 3 times 180 over pi, we are going to have a round number. In this case, we are going to round. Yeah, that's the case. So by rounding, we have 171.89. Congratulations to Danny Osorio, Tefa Cabrera, Mariana Sainz, and Danny Ruiz. Beautiful, guys. Beautiful. That was all for today. This was all I have for you guys today. I was thinking that this was going to be absolutely easy, so I decided to give it all at once for you guys. Beautiful. So let's begin with the questions now. We are going to practice a little bit. So this is what I want you to do. Work on this exercise, right? Oh, let me stop the recording now.